Well, hello everyone. I'm so glad that you're joining us. My name is Shannon Kiebler. For those of you who I have not met or who don't know me, I am the moderator of our Math Expressions user group on Facebook, as well as the creator of the Math Genius Squad, a professional development membership for those of you who use Math Expressions. So really, I'm just a teacher just like you, have been in the classroom for many years, taught all the grade levels, all the different copyrights, and now we're just figuring out great best instructional practices that work with students and with teachers. We are talking tonight about multiplying fractions and decimals. So I know you just gave a silent cheer because you're probably thinking, oh my goodness, that's like my favorite topic. So even if you teach the younger grades, I want you to keep listening because everything that we do in multiplication impacts you. So whether you're third grade, you're going to see a lot of similarities to what I'm going to show you. If you're in K1, 2, the reasonability idea is still something that you need to be aware of and be asking your students, just like we are here in our upper grades. So let's get ready here. I'm going to share with you a few different things. So again, we're talking about multiplying fractions and decimals, and we're going to talk tonight about reasonability. So I'm not going to dive into all the different models and the algorithms, although we do that with our Math Genius Squad members. So if you want to know more about the specifics about how we actually can help students visualize what's happening with multiplying fractions and decimals, let me know. If you've seen the videos in the Math Genius Squad, let me know if you need the Math Genius Squad. But fourth and fifth grade teachers, sixth grade teachers, you should definitely be watching those videos. There is a video for every single lesson where I show you how to build it with manipulatives, how to draw it, how to represent it with 10th grades, 100th grades, etc., and then how to write it and all the various ways that we will use and connect those algorithms. So tonight we're focusing mostly on the reasonability of those multiplying fractions and decimals. We're going to talk about where you can get even more support, which I just told you, and then I'm going to give you a link to a multiplying fractions and decimals game. Okay, so as we go and we talk about multiplying fractions, I'm going to give you a couple of examples here. So if I first start with a whole number multiplied by a fraction. Okay, so I have something like this. One of the key parts of the fifth grade standard is reasonability. If you look in your standards and you read about any of the operations, okay, any of the problem solving standards, everything, literally everything ends up resulting in this end quote of using reasonability. It's in so many different standards. So we know that we are not just teaching students how to multiply this whole number by a fraction. We are teaching students fraction sense. We are building on number sense to say, do you understand what's happening with these numbers and what is predictably happening with the size of these numbers? That's reasoning. What do we already know about the size of the numbers? So here's a few things I'm going to do as I teach this. So first of all, we're going to read it as it is. Everyone read it out loud. 3 times 1/4. No problem. Now I'm going to have you read it using the words wholes and parts. Okay, we're also going to use these magical words that we are really emphasizing in third grade, groups and of. Okay, so now I'm going to say I am using all of 1/4. Okay, so I'm taking 3 groups. I'm taking all of 1/4 and I'm taking it 3 times. I'm taking 3 groups of 1/4. I'm taking 3 wholes, right, like this, all of part. So now I'm using the words wholes and parts. So I'm taking all or a whole of 1/4. In fact, I'm not even just taking it 1 time, all of it 1 time. I am taking it 3 times. Okay, so I'm using this language just like if I were to use like 4 times 6. I would say 4 times 6. I would say 4 groups of 6. I would say I'm taking 4 6 times. I'm taking 3 1/4 time. I'm taking 1/4 3 times. I'm trying to rehearse language. This is going to make sense in just a moment. Because what if I turned it into now I need to take 1/2 times 1/4. Okay, let's go back up here. 3 times 1/4, all of a part. If I took all of 1/4, I'm going to get 1/4, but I'm taking all of it 3 times. I can use reasonability now to say, I know that my product has to be greater than 1/4 because I'm taking all of 1/4 at least once. And in this case, multiple times. Because now look here, I'm saying 1/2 times 1/4. Okay, I'm saying of 1/2 of 1/4. Now use parts and wholes. I'm taking a part of a part. What do we already know about the size of my answer? So if I took all of 1/4, it would be 1 times 1/4. I'm taking all of a part, but I'm not taking all. I'm taking a half. I'm taking a part of 1/4. So I already know that my answer has to be less than 1/4. Up here, it has to be greater than 1/4. And if I have reasonability, I should be able to argue this. I should be able to defend this. Now, all of these are defensible by manipulatives, by what do you call pictures, right? Bar models, number lines. In fact, remember last week we talked about bar models and number lines, and we said once you introduce it, you never let it go. So now I'd say, now show me 3 groups of 1/4 with a bar model. Show me 3 groups of 1/4 with a number line. Do the same thing here. Show me 1/2 of 1/4 using a bar model. Show me 1/2 of 1/4 using a number line. We now know the reasonability. I have to defend it with the visual. Okay, so when I look at things like this, I'm using parts, I'm using of, groups, wholes, okay, all of that kind of language. Then I want you to see now what happens if I do the exact same thing with decimals. Just because we're in decimals doesn't mean anything changed. Nothing changed. A decimal is a fraction. A fraction is a decimal. So we should be able to handle them the same way. So if I look here and I say, I want you to take 4 times 0 and 7/10. Remember, we read the whole problem every time out loud the way that the number is intended to be read. So now I have 4 groups of 0 and 7/10. What do you know about the reasonability? You're having 7/10 and you have 4 groups of them. Your number has to be greater than, my answer, my product will be greater than 0 and 7/10. What else do I know? I'm taking all of a part, and I am taking all of it 4 times because this is a whole. Okay, so now let's see, what if I did it with a fraction? Remember, everything we do, we connect. So we just came out of our fraction units. Now we're going into our decimal unit, which, by the way, friends, this is why we teach decimals after we teach fractions, okay? Because I know some of us are like, well, no, it's fractions are so hard and they understand the place value and they just get decimals clear. Okay, you can make that argument, but the problem is that you don't necessarily teach them vice versa. Like you don't go to the fraction world and say, now let me show you decimals. You can, it's just not as simple. It doesn't flow as easily. So I like to teach those decimals in the order expressions has it. Teach it after fractions. Because now I'm going to say, you don't know what happens here. And a big part of the 5th grade standard is understanding the shifts in the decimal place value system. Okay, so we're not moving decimals, we're moving digits. The digits move, the decimal point stays the same. But look at what I say now. Now I say, but just treat it like you did whole numbers and fractions. So I know that 4 is the same as 4 over 1. That's still equivalent to 4. And I still know that I'm multiplying. But what if I rewrote this as a fraction? As a fraction, or as decimal, it's 0 and 7/10. As a fraction, it is 7/10. Well, do you know how to do this? You just learned how to multiply fractions. I just put it as a fraction. Our kids are like, oh, now I know. So I know that it's 28/10, and 28/10 has to end in the tenths place value position. So it's 2 and 8/10. 28/10 is the same as 2 and 8/10. It tells me exactly where that decimal goes. Okay, so let's watch again. What if I said I want you to take a decimal by a decimal? Okay, so now I'm going to say, look, I have 3/10 times 4/10. Okay, everyone read it. 3/10 times 4/10. Read it in parts and wholes. I'm taking a part of a part. What do you already know? Reasonability about the size of my product. If I'm taking a part of 4/10, my answer has to be less than 4/10. Now I'm going to say, well, connect it. What do you already know? Well, I know this is a fraction, right? It is 3/10. What is this? 4/10. I know how to multiply fractions. It's 12/10. When I write 12, my decimal point has to be in the tenths place. So 1 and 2/10 is the same as 12/10. tenths. So my friends, as you're working through the reasonability piece, you're asking yourselves, what do I already know about the size of the existing factors? What do I already know without even doing a single piece of computation about the size of my product? Now, you might start arguing things like, but what if you have like 7 and 4/10 times 3 and 2/10? It's the same idea. I have 7 groups of 3. I have 7 groups of 3 wholes, and then I have a part of another part. Okay, now it's of course a little bit more complex than that, but we're going to show that in the area model. So now I can start to break it apart and show visually, just like I did with whole numbers. I'm not going just to a straight shortcut algorithm here. That's not the standard in 5th grade. Friends, listen to that again. That's not the standard in 5th grade. Okay, so go back and read your standards. It is not the standard that they have to do like a shortcut method. They have to build fraction sense and understand where the decimal point goes, and they understand the place value shifts. That's the standard. So as you're looking, remember, you're focused on language, rereading it multiple times. You're focused on connecting back to fractions as often as you can. And you're asking yourselves constantly, what do I already know about the size of the factors? And what do I know about the size of the products? And then you will defend it with manipulatives and visuals. And then, of course, we'll connect it to some sort of numeric method. So as you look here, I want you to know that if you are in the squad, you're going to have lots of these resources. Go watch the videos. I will teach you the different algorithms, how we connect it with what manipulatives, with what visuals. You're going to go see that. So in your squad, under stage 2, you're going to go click lesson materials. Under lesson materials, you're going to see your slides that go with this, including the work mats. So we're going to take a couple of those problems I just showed you, and I'm going to give you a work mat where students plug it in and they do it those multiple ways. But you're also going to have the video where I explain it to you. And of course, you have the slide deck to help visually guide your students through those different methods. After that, you also have, if you are in the squad, don't forget that you have the fact fluency games. Okay, so we have a whole game set for you in the small group section under fact fluency, Fluency Factory. Also in your emails, members, you're going to get this game on the matching, right? You can see it's in number lines, it's in bar models, it's matching the area model to the actual equation. How do we make all of those connections? So again, Matchina Squad members, go grab this in your fact fluency section. It's also in your small group section under Fluency Factory. If you are not a Math Genius Squad member, I'm not sure what you're waiting on, but go join, or just say me and we will get you a link to this game right away so that you can go grab just the game if you would like it. So my friends, remember that fractions and decimals are the same thing and they should be treated as the same thing. We don't have to teach separate things. We teach them together so that students understand those equivalencies. And other than that, my friends, thanks so much for joining me tonight. I have a great night and happy Math Crush Monday. Bye for now.